Hey guys, happy Halloween. We are going to do some fun integral stuff. We're going to do reverse chain rule, and then we're going to learn all sorts of fundamental theorem of calculus. Let me share my screen. Okay, so here we go, 4.1. So first it's going to kind of warm you up, have you try and integrate without knowing kind of the rules of doing it, but by kind of observing. Okay, so if I take the derivative of this, I know that this is chain rule, right? So the mom is the 4, so that's going to be 4 and then 1 plus 5x to the third, so that's the mom. And then the baby is the inside, so the derivative of this is 5. Okay, so when I go backwards here on number 3, it's having you integrate that. So we know that this is going to be the answer. So I have to figure out, how am I getting this answer, right, from this? So if I look at this, I notice that the 5 that's here is just part of the hook on, or is part of the baby. So the baby, the derivative of 5x is 5. So this 5 right here, it's not really part of the problem. It was just the hook on from the inside. So the 5 kind of just goes away. Okay, because I have to figure out that 5 was extra when I took the derivative. Okay, so the 5 is going to go away. So then I'm just taking the integral of this one. Okay. So when I do that, I'm just going to say, okay, so this is going to be 1 plus 5x. I'm going to raise the 3 to the 4th power and divide by 4 because the 5 went away. And then I add c. Of course, we're always remembering our plus c. Okay, so what about on this one? So when I take this derivative, I've got the derivative of the sine is the cosine. I leave the baby the same. Okay, and then the derivative of the baby, or the inside, is 5. So down here, when I have this 5, the 5 is extra. This is the baby, so it goes away. Okay, and then the integral of cosine is the sine, because the derivative of the sine is the cosine. So always want to make sure your signs, positive and negative, work backwards. So this is going to be the sine of 1 plus 5x plus c. Okay, so we're kind of figuring out that we hooked on the derivative of the baby up here, the derivative of the inside function. Okay, and then when we integrated and we went backwards, we had to unhook the derivative of the inside function. So that's why this 5 and this 5 went away, because it was the hook on from the inside function, so that was unhooking it. Okay, so that's kind of what we're going to be doing on the reverse chain rule, but sometimes it's not as easy to see which one is the hook on and which one is part of the real function. So on your derivative sheet, or on your trig derivative rules, you notice that we have a cosine of x was the integral. So all I'm going to do is I'm going to change the x to a u, and then I'm going to write u prime next to it. Okay, so that's what this notation means, which you'll find out as we go along more. Okay. All right. So I'm going to do this using a method called u substitution. I can't even spell substitution. Okay. So this is going to be the best way to take integrals doing reverse chain rule, because you can't lose part of the problem. Okay. So if I say I'm going to do a u substitution, so I'm going to try and take a complicated function, so in this case 3x minus 1 to the 10th, and I'm going to replace 3x minus 1 with u. Okay. Now, the thing about this is if I put a u, I have to do u prime, right? So if I do u prime, instead of writing u prime, and I want you to be really careful about this, write du, okay, so that you can see this. So I'm taking the derivative of u, so that's du, and the derivative of this is 3, but this is an x, it's not a u, so I have to have my dx next to that. Okay? So what I want you to notice is that when I replace this with a u, it's u to the 10th dx, but I can't have a dx because I'm doing the integral with respect to u. So I need to turn this dx into a du instead. So I need to solve for dx. I'm going to divide by 3, and I always put a 1/3 like this. Okay? So 1/3 times du is dx. So now instead of dx, I write 1/3 du. So we're just replacing, all this is right here was that dx that we originally had. Okay? All right, so now we're going to do the integral of u to the 10th with respect to u, so we're good to go. So that's going to be u to the 11th over 11 times 1/3 plus c. Okay, now I replace my u that I had, the 3x minus 1. I'm going to put that back in. So 3x minus 1 to the 11th over 11. And then we could put the 1/3 in front or the back. It doesn't matter. It's the same thing. And then we replace that back in there. Okay, so pause it. Go back over it again. Try to understand where the things are coming from in each part of it. Okay. If you look at this kind of in the perspective of the example that we just did, the 3x minus 1 is the inside, and the derivative of the inside, my hook on, would be a 3. So to undo my hook on, which is 3, I would have to multiply by 1/3. And that's where that 1/3 is coming from. That's undoing the hook, unhooking, right? The 1/3 is unhooking the chain rule. Okay, all right, so on this one, I notice I have this function times this function, and probably one of them is the hook on, and I got to figure out which one is the hook on. So to do that, I'm going to look at probably the higher power is usually the second part is the derivative of that one, but it's not always the case. You have to kind of play with it a little bit, okay? So here, if I take the derivative of t cubed, I get 3t squared plus 2t, and I notice that's the same thing. So this is just the hook on, okay? Well, let's go through the steps for u. So u is going to be the more complicated, t cubed plus 2t. du is 3t squared plus 2t dt, okay? I always have to write the variable with respect to it. So I have to have that dt because this was a u and a t, so I have to pay attention to which one's which, okay? I'm solving for dt, so I'm going to divide by 3t squared plus 2t. So 1 over 3t squared plus 2t times du is the same as dt, okay? So when I rewrite this, I get 3t squared plus 2t, that's this part, and then this is u, so times u, and then dt is right here, so 1 over 3t squared plus 2t du. Now we're ready to take the integral. This cancels out, okay? So I'm doing the integral of u du. You always want to write down what the final thing is before you take that integral. The integral of this is u squared over 2 plus c. Okay, then I plug in u, t cubed plus t squared over 2 plus c. And we get our answer. Okay, hopefully it's starting to make sense a little bit. All right, so if I look at this, the derivative of this is 12x squared, which I notice 6x squared will probably be cancel out, but I am going to have a little bit left over. So this isn't all hook on, okay, but it's part of it. So u is going to be 4x cubed minus 5. du is 12x squared dx. And 1 over 12x squared du is dx. Okay, we're going to get really good at doing that step right there. Setting it equal to u and then solving for dx. So this is going to be the integral of 6x squared times 1 over the square root of u times 1 over 12x squared dx. Okay, so all I did is I replaced my u here, I separated these, and then this is our, I'm sorry, I wrote x, that should be our u. So this is our dx right here. Okay, so 6 will cancel out, and it leaves a 2, and then x squared cancels out. So really, I'm looking at 1/2 u to the negative 1/2 du. Okay, so the integral of that is 1/2 u to the positive 1/2 times 2 plus c. So u to the 1/2 plus c, I know that u is 4x cubed minus 5 plus c. And we notice that that 2 canceled out the extra part, and so I just have this left over. Okay, it just worked out to work out like that. Okay, all right, so I want you to pause the video, and I want you to try the next 3, and then come back and see if you did it right. Okay, so for this one, there's not really, like if I did a hook on here, it would be 3y squared, and I notice there's not a 3y squared here. And so I'm going to have to multiply this out. So this is going to be y to the 6 plus 2y cubed plus 1 dy. And I don't need a u substitution on this one. I can just take the integral. So y to the 7th over 7 plus 2y to the 4th over 4 plus y plus c. Okay, so that one was, didn't have to have a hook on. Okay, this one is the sine of 4x. So in this case, u is going to be 4x, du is 4 dx, and 1/4 du is dx. So the integral of the sine of u times 1/4 du, and we get 1/4 times the cosine of u plus c. Now think about this. If I take the derivative of the cosine, I get a negative sign, and this isn't negative. So I do need to have a negative on there because the integral of sine is negative cosine. Okay? All right, so this is going to be negative 1/4 times the cosine of 4x plus c. 3 theta times the cosine of theta squared. If this was my baby, theta squared, the derivative of that is 2 theta. That's probably going to cancel out this theta, right? So let's say u, and this one is going to be just theta squared. Okay, so du is 2 theta d theta. 1 over 2 theta du equals d theta. The integral of 3 theta times the cosine of u times 1 over 2 theta du. So notice my theta is going to cancel out, but that 3/2 is not going to. So this is going to be the integral of a cosine is a positive sign. And then u is theta squared plus c. Okay. All right, last one, number 11. So on this one, we have a sine squared. And I know the derivative of the sine is the cosine. So cosine is going to, this is my unhook, right? So u is going to be the sine of x. U du is the cosine of x dx. 1 over cosine du equals dx. Okay, so now we've got u squared times cosine, and then dx is my 1 over cosine x du. Okay, so these are going to cancel. So anything with an x is going to cancel before you can do this problem. Okay, so this is going to be u squared over 2 plus c. U is sine, and we get the sine squared. over 2 plus c. Ooh, look what I did, you guys. This should be u cubed because it was already u squared. So sine cubed of x over 3 plus c. Okay, another way you can see this is it will say 1/3 out front, and then it will say the sine cubed of x, like that. Okay. All right, so now we're going to do a couple problems where it's complicated, and when I do a u substitution, it doesn't get rid of everything that has an x in it. So I'm going to have to manipulate the u around a little bit, because if like u equals x plus 1, then I could solve for x and say that x is u minus 1 and replace that with my x's so that all of my variables match up. Okay, so that's what this is kind of going through in these steps. So you're going to set u equal to something inside of a radical, and then you're going to end up having to solve that for u and for x. Okay, and then you substitute it back in at the end. It's going to be easier to just start going over these problems so you can see what I mean. So the radical is x minus 1. So I'm going to do the same thing. U is going to be x minus 1. Du is just dx. Okay? So I noticed that I have du equals dx. And I noticed if I replace this, I get x times u to the 1/2 du. Well, my problem is that I have this x here, and I can't take an integral with an x and a u. It has to be the same variable. So I have to somehow figure out a replacement for x that has a u in it. Okay? I need to figure out a replacement for x that has a u in it. So if I look at this original u equals x plus x minus 1, I can turn this around and solve for x by adding the 1 over. So x is equal to u plus 1. Now I can put my u plus 1 right here and times that by u to the 1/2 du. Okay? So if you have a problem that has two variables, you're going to have to manipulate your original equation somehow so that you only have one variable. Now to integrate this, I need to, because neither of these are hook-ons, right? Neither of these are the baby. So I need to distribute to both of these. So u to the 1/2 times u to the 1, I add the 1 plus the 1/2, and I get u to the 3/2. Okay, I haven't taken the integral yet, I just simplified. Now I'm going to take the integral, so I'm going to add 1 and I get 5/2, and then I divide by 5/2, which is multiplying by 2/5. Here I add 1 and I get 3/2, so 2/3. Okay, and the last thing I do is I replace u with x minus 1. So 2/5 x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3/2 plus c. Okay, so we're going to have to manipulate u a little bit. So let's try it on this one. So u equals 2x plus 3. I notice that that's not going to cross off. So I'm going to have to replace x into this. So let's solve this for x. I would do that by subtracting 3 and dividing by 2. Yeah, let's keep it all together. So u minus 3 divided by 2 is the same as x, okay? Now let's take the derivative. So du is 2 dx. So 1/2 du equals dx. Okay, now we're ready. So now I have the integral of 2x minus 1. I'm going to multiply by 1 over the square root of u. And then I'm going to times by 1/2 du. Okay, now I notice that I have an x and a u, so I can't do this yet. So I have to replace this x with this that we solved for. So u minus 3 over 2 is going to go in place of this x right here. So 2 times u minus 3 over 2. Okay, so 2 times x, so this is x, and then minus 1 times by, and I'm going to go ahead and move this u to the 1/2 right now, times by 1/2 du. Okay, we still haven't integrated. So notice that this 2 and this 2 will cancel. And then I actually want to keep this one because it will be easier to hold on to this one. So you can see that those cancel. So there's 3 of them. So really I have 2 over 4. So I'm going to have a half left. Okay, and then u minus 3 minus 1 times by u to the negative half du. Okay, a lot of distributing here, right? So we have to do times this by u to the negative half. U minus 3 minus 1 is just minus 4. Okay, so let's pull this half and distribute it. So we have 1/2 u, and then we have minus 4 times a half, so minus 2. That's going to multiply by u to the negative half. There's a couple ways you can do this. You could pull the 1/2 out from the very beginning and then multiply your answer by the 1/2. I prefer to just get it over with and not have to worry about it when I'm done. So this is going to be 1/2. 1 minus a half is just 1/2 power, and then minus 2u to the negative 1/2. All right, we are finally ready to integrate. Okay, so now when I take this integral, I get 3/2 and I multiply by 2/3, and the 2's will cancel, so I get 1/3. I'm going to add 1, I get 3/2, multiply this. Instead of 3/2 is 2/3, this would be negative 4/3. It's 1/2 because it's negative. If I add 1 to this, I actually just get 1/2, so this is just going to be 4. And then plus c. Okay, so now I replace that u, which was 2x plus 3. Make sure you guys can see my paper. Okay, and you could write it like this, or you could simplify it. Either way is fine. Okay, so you'll get to do some of these type of problems on your homework. Don't worry, you'll have a lot more practice. Okay, and then we can go over questions. But start your 4.1 homework, at least try and do the review problems. So if you can't get the first integral ones done, then do the reviews. Okay, have a good day.